this next section, in section 6.4, we're going to be asked to find probabilities or areas for a mean. Not a data value like we've been doing, but a mean of values. So what we're going to be looking at using if we're doing something like that, because we're using larger samples, is we're going to be using something called the central limit theorem. And this is going to kind of work behind the scenes in what we're doing. And what it tells us is, basically, it doesn't matter what shape picture you start out with, any one of these crazy shapes, or even the normal distribution. What it says is if you have a sample size large enough, like let's say 30 or more, what happens is they all end up looking like the same exact shape. That's why when we actually do experiments and stuff like that, we really want to have large samples. And in this case, they're saying anything bigger than 30 is a good idea. And what this says is really two pieces of information that we're going to use here. Is that when we talk about finding the mean of our sample means, it will just be our regular our regular mean. However, when we go to find the standard deviation for our sample means, because that's what we're going to be looking at is sample means, not just a regular data value, is we'll have to take the regular standard deviation and divide by the square root of n. And this little extra step has to be done. It can't be skipped. And the question is going to be recognizing how do you know when you do this one small extra step? And we'll work on that. So let's take a look at why these problems are different. Up to this point, we've had, let's say, one piece of data and one standard deviation. Now what we're going to be looking at is having standard deviations here for a bunch of samples in which we're finding the sample means. And then what we want to do is actually ask a question about the sample means and their probabilities. So everything is going to have to do with finding probabilities or areas for means. That's how we know that this section and our problems are different. And like I said before, your only real catch is if you're going to find an area or probability that you have to calculate your standard deviation first if it's one of these problems about the mean. You'll have to take the standard deviation and divide by the square root of n. And that will be going in our standard deviation slot when we do our normal CDF. Everything else will look exactly the same. So what I'd like us to do is look at a couple of questions or problems so that we can actually see how is this different from what we were doing before? How would the wording be different? How would I know to do something different? Well, let's take a look. So assume that the SAT scores are normally distributed with a mean of 1518 and a standard deviation of 325. So far, so good. This is the same type of information we received before, that we have a mean and we have a standard deviation. Okay, let's look at problem A. In problem A, we have one SAT score. That means one data value. And we want to find out that the probability of it being greater than 1600. Okay, that is what we've been doing in this chapter already, this regular 6.2, because we're only talking about one score. Let's see, we're only talking about one SAT score and whether or not it's greater than 1600. Nothing fancy. So we can draw our normal curve. We can look at our 1600 here. And that's somewhere over on the right here. And it says we want to find the probability that the score is greater than 1600, which means somewhere on this right section. So I'm trying to find my probability or my area of falling in here. So we've done this before already. We would start out with our normal We're trying to find an area, so it's just a regular normal CDF. And we'd start out with, where are we starting? We're starting our area at 1600, comma, we're going to continue on forever towards the right because we're going towards infinity, which means, just like in the past, we'll use our positive 10 to the 99th. And continuing along, we want it to do all the heavy lifting for us. We don't have z values, so we need to give the mean next, which is 1518. And the last part we need to give the calculator is the standard deviation, which is 325. Nothing special. This is exactly what we did before. So we'd go to our calculator and input this and see what we end up with. And what the calculator spits out for us is 0.40, and that's our probability. Now, let's look at part B. Part B says a little bit different. Now we're finding the probability that 64 SAT scores have a mean greater than 1600. So we're still looking at the value of greater than 1600. So we're still going to have a picture that looks very similar. We're still going to have our normal distribution. We're still going to have that we're looking at 1600, and we still want things to be greater than, so we're looking at this part of the picture. The difference and the big key is that now we're talking about a mean. When we're doing that, we have to do our extra calculation to find our standard deviation. We can't ignore the 64. That 64 is going to get used. Well, what our formula says is to find the standard deviation for our means here, because we have a mean. We take the regular standard deviation and divide by the square root of n. Well, our regular standard deviation we used in the last problem was 325. We've just got to take that and divide by the square root of our sample size. Well, our sample size is that 64 we were just talking about, so we've got to divide that by the square root of 64 and figure out what that is. Now, I would not round this value. Why? Because if we round this value, it's going to throw off our answer slightly, and that may cause some issues with my math lab. So I'm just going to plug that in as my standard deviation. So I'm going to do my normal CDF just like I did in the last one, because I'm trying to find an area or probability. I'm still starting at 1600. I am still going off to the right forever towards infinity. So I'm still going to use my positive 10 to the 99th next. Comma. I still have the same mean. The mean stays the same no matter what. We said the only thing that changes is the standard deviation. And I'm going to input it the way I have it written and let my calculator do the heavy lifting. So we're going to type in 325 divided by the square root of 64. Be careful that you close off your square root and also close off your normal CDF. And let's see what we end up with. So you'll go into your calculator, do your normal CDF of 1600, 10 to the 99, 1518 as your mean, and 325 over the square root of 64. And let's see what we end up with. For this one, we end up with a completely different answer of 0.02. Notice our answer from A to B is way different. So that one little step of finding your standard deviation because you had a mean made a huge difference. Let's try one last problem just like this. In this last problem, Mensa membership requires an IQ